In this video, we will focus on what is meant by the term coding. Coding involves writing algorithms for the system to execute. The system must be able to understand what you write. This means that you have to write your code in a programming language. Most programming languages are textual. But some programming languages also use diagrams and other constructs to make coding more visual. These languages are often called visual programming languages. We will look at Python as an example of a textual programming language. When using Python, you write code as a sequence of lines. You will see later that the procedures you write in Mobius modeler are similar to Python code. The lines of code that you write have to follow the specific rules of the programming language. This requires you to be very precise. Any small typo can cause an error. Can you spot the error in this code? In general, you can think of the code as being executed one line at a time. The lines form a linear sequence, starting from the first line. We refer to this as the sequential control flow. Later in this course, you will use conditional constructs and looping constructs. These constructs will modify the typical sequential flow. Let's look at the lines of Python code again. Each line gets executed in sequence. The lines of code are instructions to the system to do something. Together, these instructions should do something useful. When you are programming, you start with some high-level goal of something you want to do. But the system will never be able to understand that goal. What you need to do is to translate your goal into a sequence of detailed instructions. Here are the 3 instructions that this code contains. Each instruction creates a variable and assigns a value. The last instruction also performs a mathematical calculation, the result of which is 22.36. The system will execute each line of code independently. It never looks back and never looks ahead at other lines of code. The only place it can look is in its memory. Let's look at each of these 3 lines of code and see what happens to the memory. Before the first line of code is executed, the memory is empty. The line of code instructs the system to create a variable in memory called a. It then assigns a value of 10 to this variable. The memory now contains a variable called a whose value is 10. The next line of code adds another variable to the memory. It creates a variable called b and assigns the value 20. The third line of code is more interesting. It retrieves the values of the variables a and b out of memory. It then performs a mathematical calculation using those values. And finally it creates a variable called c and assigns the value 22.36. Note that when this line of code was executed, the system did not look back at the previous lines of code. It only retrieved some values from memory. After the lines of code have been executed, the memory contains 3 variables with 3 values. Let's also have a look at what happens when there is an error. Fixing errors is called debugging and is an important part of coding. With certain types of errors, such as syntax errors, the system may not be able to understand your code. In this case, even though the error is in line 3, lines 1 and 2 will also not be executed. The system will require you to fix the error before it will run any of your code. Another type of error is called a runtime error. These are errors that occur when the code is running. There are many different types of runtime error. In some cases, the runtime error will cause execution to be aborted. Let's have a closer look at this error. The first line is executed, and there is no problem. When the second line is executed, the system attempts to retrieve a variable called c from memory. However, no such variable exists in memory. As a result, the code stops executing and an error message is shown. The third line is never executed. When you run the code that is shown here, there is no output. You will not see anything. You might want to see the value of the variable called C. A very common technique when coding is printing values of variables. In Python, the print function can be used for this purpose. Most programming languages will have a similar function. Printing variable values is especially useful when debugging. In this case, the example is rather trivial. But let's say, for the sake of argument, that the value of the variable C was not what you expected. Then you could print some of the values that were used to calculate C. Seeing those values might help you discover the error. Finally, what tools should you use to write code? In theory, you don't need any specialized tools. You can code in a standard text editor. But in practice, coding is easier if you use an application that supports writing, executing, and debugging the code. Such applications are called integrated development environments. Mobius Modeler is an integrated development environment for spatial modeling.